Hello, my name is Ashley Faith, and today we are going to be walking through using Graph for effective data integration. So if you don't know me, I do have a whole YouTube channel where I teach a lot about this, and I also am in my day job, a data scientist focused on semantic search and Graph. If you want to go and check me out, I am on LinkedIn as well as YouTube. All right, so what is the problem that we're talking about here? So when you're talking about traditional data management, or data integration, sometimes you have lots of different databases or lots of different resources that you have to look at to get your information. So on one side of the coin, you can have all of these things internally. So maybe you have things on Rally, Confluence, Slack, whatever, and you don't know where to find anything. On the other side of the coin, you might be going through an acquisition, or maybe you have many, many different databases that contain data that you need to grab. So in this scenario, if I said, find all the tables and the data points where this certain customer interacts with this other customer, how would you go about doing that? In today's world, it would be very difficult to do. It would be pretty high lift if you wanted to do this. So let's look at the time that this takes. So I'm not going to go through all of these. It's actually kind of funny if you read through all of them because we have all been through this. So you have to identify the information if you're doing this without Graph. You have to then find the tables, and that can take days, and you might not even get the right ones, and you maybe have to go and shoulder tap someone to find that information. You then have to go and make sure that you can access that data because it's in a lot of different databases, a lot of different architectures. Then you have to review it, you have to mine it. All of that takes many days. Now, it's not saying that if you go with Graph to do some of these, you're not going to have all of these. But as you'll see on the other side, Graph does take some of this out of the equation where it's a little bit faster because Graph is inherently looking at the semantics between things. So in today's presentation, we're going to be talking about a very specific type of graph, and that's a hypergraph. And we're going to go through a little bit about what that means. But basically what it means is you can map these things together in a way that abstracts it away from where it is in a traditional database. So as you can see in that lift and shift or cross database mapping query strategy, it can take up to a few months to get anything done. And by the way, these times that I have on here are from my real world examples that I do in my day job. So it might be faster for you if you have a simpler data set. For me, I have a huge data set that I am dealing with billions and billions of records. So if I need to figure out where everything is in multiple databases, it can take some time. But that's where we jump over to the graph side. So on the graph side, you can actually abstract some of this stuff away where you only need to understand that hypergraph. And if you look at step 5, if you have an API or you're using GraphQL, your end users that are querying this data might not even need to know Graph either, because you can abstract it even more so that they can just query the API or using GraphQL, get the data they need without having to be a Graph expert. So let's just highlight on this side what a graph or a hypergraph does for you in the time space of a data integration or migration. So you can see that step 2 is pretty hefty here. It's not certainly as hefty as some other data integration processes in a traditional database, but what you're looking at here is think about it from an individual use case. Don't try to boil the ocean. That is my biggest advice for you. So if you are trying to go into this strategy we're going over today, start with one use case. And as you use more and more use cases and add the data to support those into your hypergraph will grow. And those little subsystems that you might actually want to strangle out are going to get smaller and smaller because a lot of the data that you need is abstracted into that hypergraph. Now, that doesn't mean that you just get rid of those other systems, but what it means is you don't necessarily have to figure out how to connect in to all of those systems all at once. And the data that does belong in those systems that you don't need at that like higher global like hypergraph level, it can stay where it is. It just means you as a giant business don't have to keep supporting that information if you don't need it for your larger use cases. So that's one tip I have, is make sure you do it from a use case perspective as your hypergraph grows out. Now, some of the other things here. So step 8 and 9, you don't necessarily need to go and find all of those missed data sets, because in step 2 of the graph side, you're going from that use case scenario and you're getting all the data that you need into the hypergraph at that stage. Now, the other nice thing about this that kind of cuts down on a lot of that time is you don't necessarily need to go and find all the experts around the company that know about this data, because the hypergraph is basically your translation service for that data. When I say customer, do you mean the same thing as customer? Maybe, maybe not, but the hypergraph will have attributes on that node, that hyper node, so that you understand if you're in this system, it's defined one way, and if you're in a different system, it's defined that way. And those subsystems are mapped to that hyper node, which is why it is so helpful, because you don't need to know all the systems that map to the node, you just need to know the node. So other things that you're going to find that are really helpful here is what you get with graph in general, which is if I am looking at queries to many different tables, and I am not the one who created those queries or those tables, and this really isn't my database, I don't really know about it, I have to kind of figure out why those queries are set up the way they are. I have to figure out, what's the maintenance like? How trustworthy is this data? A lot of those things get handled by a graph because the semantics are there. How is one node connected to another node? In a table, you don't always get the relations between data, but in a graph, that's the whole point. If you're in a regular database and you have these joins that you have to look at, many, many different joins, you might not understand why is that being joined unless somebody did a really great job at documentation. And we all know that's not always true. So in a graph, those edges can have attributes themselves. And that's where you can talk about why this join that is inherent in a graph exists at all. And this is really helpful too, because if you need to have risk assessments or really trust the data, just look at those attributes that you have in your graph and it will really help lead the way. One last thing that kind of touches on why you can shorten the time on using graph versus other means is when you are mapping lots of things together and you don't have that hyper node, they're just mapped one point to one point instead of those 2 points being mapped to a central node. What if those data points change? All of your queries break. You have to go back to square one. It's a mess. And that's what you're seeing in step 15 of the lift and shift kind of approach. But on the graph side, because we are going to be using something called a URI, kind of like a UID, that is just pointing to the original data source. So that original data source, as long as it keeps that ID, if the data values change, nothing breaks, which is so helpful when you're going through this process. I will also say from my own personal experience that one side is definitely going to take a significant amount of time if you're doing a giant data migration. So this can really change from a multi-year project, 2 years in the case that I'm talking about that I'm familiar with, versus doing it in a matter of 9 months, which is what happened when we switched to a graph solution for the migration. So let's look at this a little bit from the mapping perspective. So I was talking about a one-to-one mapping versus a graph mapping. So you're seeing that here on the screen. The graph-like structure is what we call the hub structure in the mapping space. And so the little red dot that you're seeing here tells you how many links, how many mappings you have to maintain. This is a big part of this. You can see that, if you only have a few databases or a few different tables that you're mapping, it's not terrible, right? Like if you only have up to 3, but once you get to more than 3, you're in for a lot of trouble and you're getting more risk because you don't know if any of those data sources are changing. Whereas if you're using like the hub graph model, you don't have to worry about that as much. The other thing that you get with this is you don't necessarily have to go on the hunt, right? So this is where you're trying to figure out what is it that I need? What other databases might have this information. If you start at the outset with your use case and then you build it out into this hypergraph, you're going to have a lot of those business rules baked into the graph, which is really important when you're doing GraphQL or APIs, because that's how you're going to create what those API calls are going to look like. All right, so talked about hypergraph quite a bit. What does that even mean? So a hypergraph is not that much different than a regular graph. It's just a different mechanism of creating your graph. So you can use all the same tools, Hypergraph, or any of your other graph technologies that you are familiar with in your NLP technologies. All of those work with this as well. Now, what you're looking at here is the hypergraph is like that class and node level. And then the individual data sources are being mapped up into that. So you can see that in the diagram here, where this is an example where we're looking at, let's say, session ID. You can see session ID is the same in all the different databases. Cool, that wasn't that hard. But now if you look over at user ID, wait a minute, what do you mean by user? What do I mean by user? So here in these different data sources, you can see user ID, stream ID, and stream ID. So stream ID and stream ID, that's easy. But is user ID the same thing? That's what this hypergraph will help you do, is you don't have to figure that out. You do the mapping at the outset, and then when you hand it over to your analysts, or if you're the one who is doing the analytics on this, you just have to query the hypernode instead of all the other databases. Now, the thing that you have to keep in mind here is I'm talking database, data source, just to keep it at a high enough level, but you can go down to the table, down to the field, or even the value level. So for instance, if you have controlled lists, you can say that this controlled list value of Nike is the same as Nike Co, or whatever it is in another data source. So you can do a mapping even on your control vocabularies and that sort of data. The other thing you want to think about is this is a bridge between what all of the different data sources are using, and you don't have to lift all the data up and move it. So high duplication is decreased significantly when you are using a graph-like model to do your integrations and migrations. When you're looking at this as well, I mentioned that it decreases that risk. Well, this also helps with that auditing, because when you want to do auditing, doing auditing on many different databases or many different data sources is super difficult to do until you will really build it up into this hypergraph. And then all you were doing is auditing the hypergraph, and that trickles down into the other graph databases without you having to dig into them. All right, so let's talk about how do you actually do this. So step one is you have to have URIs or UIDs. So you don't necessarily have to have URIs right away. Some of the things that we're talking about here are things that are often used in like that RDF triple store space, but there's absolutely no reason you can't use very similar methods in a property graph. And I use this all the time in a property graph. So if you have those UIDs and you can connect them together, well, first of all, the IDs are the same, which you can see in the diagram here. Fabulous. I can figure out if all of these different people in my HR database are the same, even if I'm looking across different databases. That's an ideal solution, because then the IDs are the same. But you don't always get the best use case, right? Sometimes you have to figure out how to connect different data, even if it doesn't have the same UID. So just keep that in mind. This is not a silver bullet. You do have to do some work to get it set up and working. But believe me, with all of the benefits you get from a cost, maintenance, risk, and time perspective, is really worth it. So when you're building out those URIs, just make sure that you have some kind of unique identifier associated with your data. And if you don't, just add it. It's not as difficult. Usually we all have some kind of key value pair in our data. You can use that to build out your UIDs. Now, there are best practices for creating good UIDs. So make sure you look at that before you just slap the key value pairs in as your UID, because that's not always going to work the way you think it's going to work. So when you're building these out, a lot of people use linked data practices to do this. Now, when you're talking linked data, it usually means that you're linking out to an external data source and you're grabbing data in. You don't need to do that. What you can do is you can have a resolvable link. That's what the hypergraph is really providing to you, is that hypergraph is the node that's containing all the mappings. But guess what? You're not lifting all the data and mapping it into a new data source. What you're doing is you're basically creating URL pointers, or if you're using an API, some kind of pointer back into the original data sources, so that when you query that hypernode, you're really being able to suck up all the data from those other databases. That's the key to all of this working the way that you think it's going to work. And this does work if you're doing an acquisition. If you don't even have access to some of these data sources, sometimes it's as easy as asking them to just put an API on it and helping you build that out so that you can query into the data and you don't have to keep lifting it up and copying it over and over and over again, which we all know is time consuming and very costly. So when you are looking at the URIs, just keep in mind, they don't have to be public. They do have to be truly unique. Sometimes different databases will have the same IDs, so they're not really unique. They're just unique to that database. Just be on the lookout for that. And then also, if you don't have, if you have competing UIDs, also look for that, because sometimes a UID might be unique to a certain key value pair for, like a ID, database ID perspective, like asset ID and database ID. Maybe that's the key value pair. Just be careful and make sure that it's not duplicated in any of the systems, because I've done that on accident and I overwrote a lot of data. Good thing it wasn't in production. So just don't do that. Okay, so second step. First of all, always go from your first use case and build it out. Don't try to do an entire replatforming all in one go. I have done that and it has not worked well, and it is very costly and it is very, very risky because you don't know if it's going to actually complete. So make sure you build it out iteratively so that you're looking at the highest value stuff first in your MVP, and then you start to build it out more from there. So here we're looking at an example. For those that don't know, the Microsoft, Xbox folks bought Bethesda, which is a video game company. And then they also bought Activision Blizzard stuff. And I think Activision got sliced out somehow recently. So there's a lot of things going on acquisition-wise in the video game industry. So what if I needed to find out what the server load is, because I'm taking on all those servers in my acquisition? Okay, now I need to understand a lot of the data. And these are old, tried and true systems. It's going to be really hard to crack into them, and it's going to be really hard for me to migrate them all into the same database. Well, using this approach, you don't have to. So what you're going to do first is identify what is the MVP for those individual data sources using your main use case. So in our use case, we're looking at session IDs, we're looking at when they access, and we're also looking at things like what was the server and what was the stream ID, so that I can figure out what was the volume of players on specific dates and times for specific servers. So I can understand with our new migration strategy if those servers are going to cut it for all of our user base if it grows. So this is a very real use case for a lot of us when we're going through this process. So the other thing you want to do is things that are exact matches, you put those in green. I color code everything. You can use however method you like. Then you look at things that are probably close matches, and you definitely want to get some kind of similarity score on those if you're using a machine learning technique for matching, or get SMEs involved if you are using a more manual approach. Depending on your use case, I hope you're not using manual, but that's up to you. The other thing you want to highlight while you go through this is things that maybe show up in 2 or more of the databases, but you don't know if it's MVP and you don't know if it's critical for all of the different databases to basically talk to one another from the hypergraph. So those I usually highlight in yellow. That's not a mandatory step here, but I like to do that so that I don't leave any data on the table that I might wish I had later on. Good thing about Graph, it's very flexible. So if I did forget something, I can easily add it in. I just like to do it at this stage because I'm already doing some of that mapping. Okay, step 2. Yeah, step 2. No, step 3. There we go. Step 3. So step 3 is make it queryable. So now we already understand the MVP data. We have identified what tables and fields and things in the individual databases mean the same thing or something that is similar. And now we can do the mapping in the graph. So this is a very simplistic model here that I'm showing you, but what you're going to look at is every blue node is a hypernode, and it's clustering together the things that are like-minded. So you'll see here, like the activity time, some of these will be formatted differently, but we do know they are similar enough to be used. Now, also keep in mind, I am noting the source of those individual databases in the metadata. Now, the reason that I'm doing that is so that if I needed to backtrack or if I needed to roll back something, or I needed to ask an SME, if we can update something, I can do that because I can track it back. I have that fidelity to get back to the original data source. And you can see it's looking very similar to other graph-like solutions at that hypergraph level, where you can see that session ID, active player, user ID. So you're creating those structures that you are very familiar in the graph space so that you can do graph queries on this, or you can construct a graph query that is then accessed through some kind of API approach. These are all functioning off of those UIDs. So the Hypernode will have its own ID, and then it will basically be pointing. It'll say, oh, see also, or it can say, same as, that kind of relationship to the individual database and its URI, so that it can then grab that data when it is getting queried at that hypergraph level. Now, the other thing that is nice is that Hypernode can have its own metadata as well, which is great. So you can say when it was created, what use case was it created for. This is kind of like a data catalog sort of thing as well. And if you want to do it in that way, it's very, very helpful. It's not mandatory, but it is a good way to do data migrations like this. On the other side of the coin, you'll see that there are some yellow highlights. Those are the yellow highlights from the previous step, where these are data points. You can see there's only 2 out of the 3 data sources actually have these. I keep these in and then I put a time clock on them. So depending on how long you want to keep this information into the hypergraph, just to see if it's going to be used. So I don't like to go past like a 6 to 9 month period, maybe go a year. But if this data isn't used, it's just like your closet. If you didn't wear it for a year, just get rid of it. So that's at the hypergraph level. You, of course, don't have to get rid of things at the individual database level. This is kind of where like those data-driven, domain-driven design comes into play, where if the domain needs it, but the larger graph doesn't, that's fine. They continue to maintain it, but they're the ones who pay for it and not you, right? And that's the beauty of this, is when you're going through and doing data cleanup or data integrations with additional things, you don't have to go through all this data that is just superfluous, and you don't necessarily need it for all of the global use cases you have in your hypergraph. All right, so with that, I really hope that you have enjoyed this presentation. The last step in all of this is really making sure that you go back to that main use case and the persona, the people in your internal or external user groups, can actually do the queries at the hypergraph level, making sure that you set up those APIs for their specific use cases. All of that goes into the very last step to make sure that what you have done is effective and actionable. All right, so with that, I have been Ashley Faith talking to you about how you can do effective data migration and integration with a graph-like structure. And I hope that this has encouraged you to start to look into that for yourself.